The club has received an anonymous donation of $1,000 to go to local impact STEM and robotics activities. So this is money generously given by a member for the club to give to worthy high school STEM robotics teams. Now you might think, dude, why is a radio club, VWS, giving to high school robotics teams? Because they no longer have wireless amateur radio clubs. But they have something really close that's really adjacent. Those are the robotics teams. These are the kind of kids that deserve our support. These are the kind of programs that deserve our support. So I've kindly asked these guys to come to us. In this case, it's Woodson Robotics. I've asked them to come and spend just a couple minutes with us and tell all of you, you smarty pants radio people, why you should support robotics teams at Woodson High School. And my answer to that is, and I'll make it fast, the overlap is incredible. The kind of people in our club come from the kind of people that are in that activity. So I am thrilled that we are able to support them, and I'm thrilled that they're here to come to explain to the rest of you why I think that's a great idea, and I know many of you do too. So I'm going to introduce Brian Willis. He's going to introduce the team. They've got a few minutes to make their case to you, then we're going to have a few minutes of Q&A, and then we're going to get on with the rest of the club. They're going first because they have to go home and study.
Hi, thanks, John. So I got pulled into this last year by my son in terms of participating in this this activity in terms of the capabilities associated with it. So as an amateur radio operator and various backgrounds in electronics, it sort of was a good fit in terms of the various ways that it supported and fostered children in STEM activities. So I was super impressed. And last year was my first year. We managed to do so well that we qualified for going all the way to the international competition in Houston. But the main thing is this doesn't happen without community support. One being in terms of mentors and capabilities, spaces, but also equipment, because the registration fees are in the thousands of dollars. And we all know electronics are not cheap. And the robots tend to be big and heavy and do crazy type of work. But I want to part of this is the kids need to be able to fundraise for themselves. So they need to advocate for themselves. They need outreach to groups like ours in terms of advocating why they're important in terms of STEM activities and what learning that supports. So they've created a small slide deck. So I want to let them speak more than myself. And then anything they miss, I'll come back and talk about. And we do have one other robotics mentor who's also a member of this club, Sean. I'm trying to remember his last name. I'm sorry, but he is also a robotics mentor for another team. So we are strong in terms of people who are already participating in robotics, and I think it's an important thing if this club can support those functions. Great. So anyway, without further ado, here are the students from Woodson High School.
Hi, thank you so much for welcoming us here. So we are Cavbotics, the team from CG Woodson High School, and go to the next. So we are a student-led, mentor-guided team, meaning that the students in the club do everything. We build everything, and we teach all of our new members everything that they need to know for the competitions. Everyone is fully welcome to experience STEM to the greatest of our capabilities, seeing as we don't require any fees, but we offer everyone the same chance to build, test, program a robot that will eventually go into a competition, and they'll get to experience that too. Meaning we also do all of the fundraising and business and budgeting, so people can get experience in many different fields being in our club.
All right. Hi, guys. I'm Michael. I manage, I'll just come over here, the outreach and financing of the club. We're lucky today. Our club is I think over 100 people, but we have people, the president here today. We have people from electrical, mechanical, and myself. But I think it's probably a good idea to go over what is FIRST Robotics. I've heard people compare it to BattleBots before. In a sense, it's kind of like BattleBots. It's not exactly like it. To give a quick overview, So there are different levels of FIRST Robotics. There's an elementary school level for elementary schoolers. There's a middle school level, and we're the high school level. Every year we get assigned a competition. We don't know what it is until the competition starts. And we have, what is it, like 2 months? We only have 6 weeks to build a robot, probably around the size of half that table, in 6 months. And we have to do it from the ground up every year. Yeah, 6 weeks to build it. It's a lot of fun. We compete against teams from around the world, and so we just wanted to introduce ourselves, and we can go to the next slide. All right, so obviously, since this is a radio club, we want to talk a little bit more about the electrics that go into our robot. So, do you want to? You guys want to talk a little bit about it?
Since we don't really have anyone from specifically electrical here right now. Hi, I'm Riley. I'm from the programming team. I'm assistant captain for our programming. So electrical on the robot is very important, obviously. Hi, I'm Alex. I'm the mechanical. I am the mechanical captain, but I also sort of know some of electrical. So yeah, basically what we do is our robot, we have a lot of motors on there and we got to make it move. We got to make everything move. And so we need to route power and signal and all those other things around the robot. And we have a lot of electrical components to do so. And we need to control the robot we control the robot wirelessly from our driver station. So we do have a radio on there. I mean, of course, but go to the next slide. So the picture on the left, you'll see this is most of our important electronics components here. Sorry if it looks a little messy. This orange board is what distributes all of our power. So this sends power to all of our electronics on the robot. And then over on the left, that black box is our radio. And this is what communicates with our driver station as well as sends signal to the main controller, which is that gray board. And this is where all of our robot code runs. And so we can control the robot through there pretty much. In the middle, we have a sensor, which is used to detect when one of these enters our robot. So we need to know exactly when this is in our robot because what we do is we have wheels that take this in. So they're going to be spinning and they're going to be pulling this in. And we need to know when to stop those wheels. So we have a sensor right next to this piece that'll tell us when it's in the robot. And on the right, we have a couple cameras on the robot to use with our automated computer vision system to know exactly where the robot is and what it's looking at.
Does anyone have any questions?
Yeah, so most of the components on the robot use 12 volts, but some will use lower at 5 volts. So we have some voltage regulators to step it down. Okay, so generally over the course of a match, we'll pretty much about use up a full car battery. I honestly don't really know how many that is in watt hours, but we use 12 volts and at least 50 amps or so pretty consistently for 2 minutes. Yeah, so for programming wise, we use almost completely all just straight Java, mainly not because it's particularly an efficient language a lot of the time, but it's also extremely documented for the first competition, and our school also teaches Java in AP Computer Science and AP Data Structures, which for people coming into the club who will
be going into programming, it's good to use a programming language that the school is already teaching. We have the RoboRio, which is the gray box on the previous slide, but we're not allowed to open them up. So I couldn't tell you exactly what's inside of it. So we use, so the base is VS Code, Visual Studio Code, but there's also an extension provided by First WPI Lib, which is a library that gives extra extensions and extra functions specifically for the first competition. It's like a standalone download. And then for actually deploying code onto the robot, we use another first provided program called Driver Station, which allows us to turn on and off the robot code and deploy new code onto the robot.
So we use motor controllers meant for these motors. So all of our components pretty much are meant for FRC, which is our robotics competition. So like our motors and our motor controllers are custom designed for this competition. We use Onshape. Onshape is kind of just what we've been using traditionally, and it's provided free by FCPS.
So all of our students have access to that software.
Also, in some classes, our teacher teaches CAD.
Yeah, so we use Onshape because, first of all, it's free to access for all of our students in our county, and also because there's STEM design classes offered in our school that specifically use Onshape. So it's more easy for the students who are coming in from our STEM design classes into our club to, get acclimated to working and CADing for our robot.
So the competitions are spread out between a few levels. So I would say there's like the regional district competitions, which take place at, high schools, almost like this one. You usually participate in 2 of those, and depending on how you do, you go on to our district's championship, which for this area is the Chesapeake Championship. Let me move forward a little bit. That I would say usually consists of around 80 teams. And I think it's around the top 15 teams that do well there go to the World Championships. So there are teams from, Asia, Europe, all over the world that go to Houston, depending on how they participate in those district competitions. Yeah, that's actually okay. That's a good question. Yeah. So in a competition, our robot has to compete, like I said earlier, in a series of tasks. So last year's, as you can see with these pieces here, I think we have another piece somewhere. So yeah, right, like this big green ball. So last year we had to place these white pipes, which were called coral, onto like a coral reef essentially, which was just a bunch of PVC pipes built up. And your robot would have pretty much an elevator that would grab that, as seen in the diagram, and place them onto the reef. So how the competition is laid out is there are alliances of 3. So it's almost like a 3 versus 3 competition. And whoever wins is always based on who scores the most points. So for last year's case, it was whoever put the most coral onto the reef. We use a lot of 3D printed parts actually, yeah, and that is that's what we use Onshape for as well. So we CAD a lot of custom parts, we print them, and then we use them on the bot. And I would say a lot of our bot is actually 3D printed parts. Yeah, so a lot of pieces. Oh my God, that's a good question. The game field, I don't know the exact measurements. I would say
It's like from one side of this room.
I would essentially say it's around like the size of this room, like about the length of this room, a basketball court, essentially. Yeah. So that's how, so you can imagine when you're sitting up in the stands, it is a pretty big playing field. And the bots are pretty big as well. That's why it has to be, the size that it is. Artificial intelligence. I can hand that over to programming, but I know some teams do. I don't.
So we do not actually use any artificial intelligence in ours. We don't really have the skill to do that yet, even if we wanted to. But there have been some other teams who have won awards for using some. I don't remember if it's exactly like specifically an artificial intelligence network, but they had a system where they could just press a button on their controller, and it would automatically like find a coral and then find the nearest reef level to put it onto, and then it's literally just press a button and let everything else happen, which was cool, but also way out of our league.
So thanks for giving us the time to present and giving an opportunity for funding. It's fantastic to have, the fostering of young minds like this is fantastic. I really appreciate the time. But other aspects that this is rapid engineering, which is the kind of best engineering because it's the kind that is done under pressure. And under constraints, and you learn the most from that. And you make a lot of mistakes. And that's what we sort of let these kids do as part of this. As mentors, I'm not designing things. I'm helping them design something, but I'm standing back for most of this. There are multiple disciplines involved here in terms of programming, electrical and mechanical. But then there's outreach, there's social media. So there's a whole myriad of different things the kids can enter into and do. And at least from the deployment of the robot, it ends up being like a three-legged stool because everything has to work. You have to have electrical working, programming, and mechanical. Any collapse in one of those areas makes the whole thing not work. So it's team effort, but also in terms of the actual competition, we talked about their alliances. So they have to work with one team while they're competing against others. And the next match, that team you were competing against, you may now have to work with. So there's just amazing aspects related in terms of how the kids learn to work with themselves as a team, but also just random people as a team, the kind of thing you'd have to do in a workplace. So it's really amazing. So thank you so much, guys.
Thank you so much. You guys did great. Thank you so much for coming. We very much appreciate your time, and you are all very talented, and you're all going to do great stuff. And we are excited about the opportunity to support you guys. So thank you.